Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this. I'll title it how I title it in the title. But what I am sure of are two goals for the day. Our first goal is going to be to investigate the initial conditions that lead to a kite. Our second goal is going to be to investigate the initial conditions that lead to an isosceles trapezoid. Tongue twister. All right. So without further ado, let's jump into our first goal. Let's review a kite. A kite is a quadrilateral that has two pairs of congruent sides where opposite sides are not congruent. So here I have one pair of congruent sides. Here's my second pair of congruent sides, but opposite sides are not congruent. This is a kite. So we're going to look at conditions that lead to this being the result. So in the previous lesson, we saw a kite had four properties. The first property was a diagonal bisects one pair of opposite angles. The second property was the other pair of opposite angles are congruent. The third property was diagonals are perpendicular. And the fourth property is the diagonal from one bisects the other diagonal. Both diagonals are not bisected, just one. Alrighty, so let's start off with one being our initial condition, and let's see if it leads to this shape being a kite. So here I have angle B being bisected and angle D being bisected, but they're not the same angles. Okay, they're not congruent, they're just bisected. So maybe, why don't you hit pause and see if you can figure out how we're going to get to this result from this starting point. So I would hit pause if I were you and give it a shot on our own. Hopefully you hit pause because I'm back. All right, so we do have congruent triangles here. This is not a very good marker. You are tired. And where is a good marker? Let's hope one of these are good. All right. We have congruent triangles. Right? I can say that triangle ABD is congruent to triangle CBD. And the reason why is, let me mark the hidden congruence. The reason why is I have the angle, side, angle pattern, right? Angle, side, angle pattern. Now, because I have congruent triangles, that means the parts in the same position are congruent, right? And since we're trying to argue that we have a kite, we're only interested in the side lengths. Okay, we're only interested in the side lengths. All right, so let's list it here. I know that AB is congruent to CB. I learn how to write a B. Okay. I also know that BD is congruent to BD, but that's the common side, nothing interesting there. I do know that DA is also congruent to DC. And if we were to mark these on our kite, we see AB congruent to CB and DA congruent to DC. We see that we have two pairs of congruent sides where opposite sides are not congruent. Okay, I can't assume that the opposite sides are congruent. I can't. Just like I couldn't assume that opposite angles were congruent. So this initial condition leads to a kite. So condition I okay. So I'm gonna come back. We'll talk about starting off with the second condition, and then I'll show you how we move on from there. So let me clean all this up, and I'll be back. I'm back. So let's go ahead and continue with our first goal, and that's investigating the initial conditions that lead to a kite. So first we saw the first condition did lead to a kite, so now let's look at the second condition. Is having one pair of congruent opposite angles, or the second initial condition, good enough to have a kite, or the second property, good enough to go backwards and have a kite? So if we add diagonal BD to this, do I have enough information, enough congruences to get two congruent triangles? So why don't you hit pause, see if you can figure that out. I hope you hit pause and try and figure it out on your own, because if you don't hit pause, you don't try on your own, you don't learn. So I hope you try here. So does adding diagonal BD, is that enough to get congruent triangles? So hopefully you hit pause, I'm back. The answer is no. We cannot get congruent triangles from that. We cannot get congruent triangles. Okay, so one pair of congruent opposite angles is not good enough to get congruent triangles. So starting off with a pair of opposite congruent angles is not good. All right, so number 2 is no good. All right, so let's combine ideas 2 and idea 3. We're gonna count. Ideas 3 and idea 4, which means that we have perpendicular diagonals where one diagonal bisects the other. Is this good enough to have a kite? Well, why don't you hit pause and see if you can figure this one out. I hope that you hit pause and see if you can figure it out, because I'm going to work them out here in a second. So I hope that you hit pause. I really do. All right, and hopefully you hit pause, and I'm back. All right, so first of all, if two lines intersect and one angle is a right angle, that means that every angle is a right angle, because these two angles add to 180. So do these two, and these two are vertical, so they have to be equal. So I get 4 right angles, right? So if I know one angle is a right angle, I get 4 right angles. All right. So do I have enough information to have congruent triangles? I do. I do. So first, I get triangle AEB congruent to triangle CEB. Okay, so let me write that out, and hopefully you can figure out why. Even though it's a right angle, that doesn't mean we automatically default to hypotenuse leg. It's actually side angle side. And because these guys are congruent by side angle side, and I can list the congruent corresponding parts, and I'm really only interested in, did I argue that BA is congruent to BC? And if I look at the order that I wrote them, BA is congruent to BC. So the congruent corresponding part that I'm interested in is BA congruent to BC. Okay, I'm going to mark that on here. BA congruent to BC. Okay. Now, I can't assume that this is the same as that. So what I'm going to do is I'm going to put 5 marks here. 1, 2, 3, 4, 5. And again, I get 2 congruent triangles because of side angle side. So the second triangle, AED, is congruent to CED because of side angle side. And again, the congruent corresponding parts I'm interested in is AD the same as CD, right? So the congruent corresponding part that I'm interested in is DA is congruent to DC, right? And so this means that I have a kite. So the condition, the combination of the property of 3 and 4 will allow me to get back to as an initial condition, will allow me to get back to a kite. So we get to a kite if diagonals are perpendicular and one diagonal bisects each other. So this will generate a kite. This is good enough for a kite. Alrighty, so what I'm going to do is clean all this up, check, oh, actually not first, I'm going to check this off because I did the first goal. Clean all this up, come back with the second goal, and I will be back. I'm back, so let's go ahead and start our second goal, and that's going to be to investigate the initial conditions that lead to an isosceles trapezoid. So let's start with a trapezoid that has one pair of congruent base angles. This is our initial condition. And is this enough to end up with an isosceles trapezoid? Meaning, does this initial condition of one pair of congruent base angles, is that good enough for us to have, or us to argue, or us to show that side RU is congruent to side ST? These would be congruent legs, which would mean we'd have an isosceles trapezoid. So, does having these congruent base angles allow us to get to this conclusion? Now, this is not a congruent triangles argument. So I'm going to walk through and I'm going to just show you how the argument is made. If you follow along, that's exactly where I need you to be. Alrighty, so it's really a clever argument, and to be honest, I don't think I could ever come up with this on my own. I'm just telling you a story that somebody else already has done. Okay, so like before, we're going to add segment SV so it is parallel to RU, side RU. So I'm going to add SV so it's parallel to RU, okay? And we now have parallelogram RSVU. So by us adding this, we got to a parallelogram, and we did that so that we can unlock the properties of the parallelogram, okay? So now we get to use the properties of the parallelogram. I repeat myself a lot. I should probably read what I write before I speak. So what that means is side RU is congruent to side SV because opposite sides of a parallelogram are congruent. So I'm going to mark that in red. Side RU is congruent to side SV because opposite sides are congruent. And the measure of angle U plus the measure of angle 1 add to 180 because consecutive angles of parallelograms are supplementary. I know these guys add up to 180 degrees. You're going to see why I'm doing this here shortly, okay? I'm trying to create something in here, okay, in this triangle. But I need to use this fact. All right, angle 1 and angle 2 are supplementary because they are a linear pair. So measure of angle 1 plus the measure of angle 2 add to 180 degrees. Now we're in a spot where I can get these guys together. So again, like I said, I want to be able to argue something about U and angle 2, and you'll see kind of how things start to come together here. All right, so let's see here. Oh, this is all right. We used the transitive property, we brought these guys together, and guess what? I can subtract away the measure of angle 1. So that means now I'm left with the measure of angle U equals the measure of, that's a terrible M, measure of angle 2. I'll try and fix that. But the measure of angle U equals the measure of angle 2. Well, guess who else equals the measure of angle U? The measure of angle T. That's what we started with. Remember that. And that's a terrible. I should write better. And the measure of angle U equals the measure of angle T, because that's what we started with. Well, guess what? Angle 2 and angle T both equal the measure of angle U, so again, by the transitive, I can say that the measure of angle 2 equals the measure of angle T. All right. So what that means is that triangle STV has two congruent base angles. All right, where am I? STV, right? So I correctly argued that these guys are congruent. Well, if these guys are congruent, then that means that ST must be congruent to SV, right? We have an isosceles triangle. So that means that SV is congruent to ST because congruent base angles lead to isosceles triangles from an earlier idea, right? So now I know that these guys are congruent, right? But earlier, I just saw that SV was congruent to RU. So since SV is congruent to RU and SV is congruent to ST, by the transitive property, I can now say that RU is congruent to ST, which is what I wanted to show. I wanted to get to this. I got to that, but again, it was a very clever argument. So this is a good enough initial condition. We only need one pair, but this is a good enough initial condition to make an isosceles trapezoid. So this gives us isosceles trapezoids. Let me highlight that. So we get that. Two congruent base angles is good enough for an isosceles trapezoid. Two congruent, I'm out of room, I'm sorry. Two congruent base angles are good enough for isosceles trapezoid. I'm going to say triangle. And I'm forgetting my writing, it's really bad. Alrighty, so let me clean this up. I'm going to set up the next initial condition that we'll see if it leads to a isosceles trapezoid. So again, let me clean all this up and I'll be back. I'm back for the last time, I promise. So let's go ahead and investigate the initial conditions that lead to an isosceles trapezoid. This is the second part. Now I'm leaving out the third initial condition that leads to an isosceles trapezoid because the book doesn't mention it. But maybe I'll make it a problem, I don't know. We'll see. Anyways, is a trapezoid with congruent triangles an isosceles trapezoid? So basically, if diagonal BD is congruent to the diagonal CA, does that make trapezoid ABCD an isosceles trapezoid? Remember, in order to show an isosceles trapezoid, I have to argue, right? We have to argue, we need to show that BA is congruent to CD. We need to show that the legs are congruent. All right, that's how we determine if we have an isosceles trapezoid. So if we look at the two triangles with segment BD in it, so we can look at a triangle ABD, right? ABD, and diagonal CA, so DCA, this guy, DCA, and there's our congruent diagonals. And then AD is congruent to itself because it's part of both triangles. we get the following, which is not enough to get congruent triangles. So right now it appears that congruent diagonals is not enough to get congruent triangles, which would allow us to get to congruent legs, which would allow us to have an isosceles trapezoid. Now, this is a very creative workaround. It's really neat what someone figured out at some point. So what they're going to do, and what we're going to do, is we're going to put a rectangle in our trapezoid ABCD, and we're going to call it rectangle BCEF, okay? So BCEF. And it's a real clever workaround because, again, we didn't have enough in these triangles to get congruent triangles, but when we make rectangle BCEF, we're going to be able to add a congruence to this. So let's see how this is done. All right, because BCEF is a rectangle, opposite sides are congruent. So because BCEF is a rectangle, opposite sides are congruent. So CE will be congruent to BF. And if we look at triangles BDF, so BDF, and triangle CAE, we can say that triangle BDF and triangle CAE, oh, there's an email, are congruent by a hypotenuse leg, right? I have a pair of hypotenuses that are congruent and a pair of legs that are congruent. So we have congruent triangles. Okay, now what's important, and this is why this is done, okay? This angle D is that angle D. And this angle A is that angle A. And so by us adding a rectangle and not looking at side BA, but in fact side BF, and not side CD, but side CE, we can get to the point where these are congruent corresponding parts of these triangles. So angle A and angle D are congruent because they're congruent corresponding parts, right? D and A. And so if we add that congruence to this, we now have congruent triangles BDA congruent to triangles CAD by side angle side. And by corresponding parts of congruent triangles are congruent, that means that I can say that AB is congruent to DC. Again, that's what I needed to argue, or BA congruent to CD. That's what I needed to argue in order to determine if congruent diagonals was enough to have an isosceles triangle. So I have congruent legs. It's been argued. I have congruent legs. So yes, this is good enough to have an isosceles trapezoid. So let me write this sloppily across the bottom. We'll just put a box. Yes, congruent diagonals lead to ISOSCELES, isosceles trapezoids. All right, and I concluded the goal, and this concludes the lesson. Hopefully you understand how to use this information in the homework. I'm going to go ahead and end this here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.